Hi again. We're going to do a little bit more work with law of sines. This time we're going to be given triangles where I have an angle which is acute, and then I have a side, and the next side is shorter than the first side I was given. So the side opposite the angle is shorter. So here's one example. So I have an angle that's 25 degrees. I don't know how long this is. And this is about 25 degrees. And what I do know is that this is 12. B is somewhere down here. I don't know where the vertex B is, so it's somewhere down here. But I do know that A is 4, and 4 is shorter than 12. What's going to happen in this case is the 4 is going to be about that long, and there is no way that we're ever going to be touching this ray of this angle. So no triangle is going to be formed. If you set this up with your calculator, what you would do is try to find what this angle is, and you could say sine B over 12 is equal to sine 25 over 4. And what you're going to end up with is an error in your calculator. And the reason is because this side is too short and you're never going to be able to make a triangle. Now, if I was curious about how long a side would have to be, if it were going to come down and make exactly one triangle, what I could do is I could use a tangent function just to see what that would be. So I'm going to say that the tangent of 25 is equal to opposite, so that would be this, over hypotenuse. And if I solve for x, multiply both sides by 12, make sure that I'm in degree mode, I get x is about 5.07. So if x was 5.07, then it would be coming straight down, making a right triangle, and then I would have one solution for this. But as it is, 4 is never going to be able to reach down to the bottom, down to this ray. So no triangle in this case. So this time, I have my angle is 25 degrees, so the angle is still the same as it was in the last example. Again, I don't know where B is, so I'm going to make this kind of long. Here's about a 25 degree angle. So this is A, and B is 12. So B is somewhere down here, I don't know where, and A is 14. This time A is longer than B. So the only possible thing that can happen is that my side has to be coming out like this. So this would be 14, and I'm going to have exactly one triangle. So I'm going to solve the triangle, which means I need to find all the angles, I need to find all the sides. So I know I'm going to have exactly one triangle, so I'm going to use the law of sines to find B. So I'm going to say sine of B over 12 is equal to sine 25 over 14. I want to solve for sine B. And in my calculator, what I want to do is find the arc sine of B. I'm finding the angle. So I can do this, the arc sine, and this is what I want to type into my calculator is all of this. 12 times sine 25. Make sure that you keep your parentheses here, divided by 14. And that's going to give me B. I'm writing approximately B because I am going to have to round. So B is about 21.2 degrees. I know I keep saying this, but check your mode. Make sure you're in degree mode. So now I want to find the angle C, which is right here, and I'm also going to have to find little c, the length from A to B. Finding this angle is pretty easy. All I need to do is take 180 and subtract 25, subtract 21.2, and this is 133.8. And to find C, all I need to do is a law of sines. I can use a law of sines because I do have an angle on the side opposite. So I want sine 133.8 divided by c is equal to, and I'm going to use these measurements because I was given these, sine 25 over 14. And then solving for c, I get about 23.9. So I have the triangle solved. In this next example, I kept the angle measurement of A exactly the same and B exactly the same as what it's been in the last couple of examples. But this time A is equal to 6. Now, if you remember back a couple examples ago, when we had this example and A was 4 and we didn't have a triangle, when I tried to figure out what it would be if I had exactly one triangle, I got the tangent of 25 is x over 12, and x was 5.07. So if x is 5.07, I'll have exactly one triangle. But in this case, I've got A is 6. So that's a little bit larger than the 5.07 that it would be to make one triangle. So I'm going to draw my triangle. I know this is bigger than 25 degrees, but that doesn't matter. I'm just going to use it to represent my triangle, so I don't have to be to scale. So this is 25, B is 12, and A is 6. So what's going to happen in this case is 6 can come out like this, but 6 can also swing in. So let me show you what happens on the calculator when we try to solve this triangle. So here's the triangle again, looks a little bit nicer. And this is 6. Now, this is 6 and it swings out. On your calculator, when you solve this, you have the sine of 25 over 6 is equal to sine B over 12. When I solve for B, remember I'm going to have to use the arc sine to find B, I get B is about 57.7 degrees. Now, here's what your calculator does not tell you that you need to recognize. Anytime you have a side-side angle and this side is shorter than the side that makes up the angle, if you have a triangle that's 57.7 degrees, then you can also have another triangle. You also will have another triangle where it swings in. This 6 swings in also. So you have two triangles. So just because the calculator gives you the 57.7, that's right, but that doesn't mean that that's your only triangle. Watch what else can happen. That 6 could also be swinging in like this. Now, this makes a nice little isosceles triangle. This is 6. This is also 6. Now, if I know that this is 57.7, and I know that base angles of an isosceles triangle are congruent, then I can also calculate this angle right here. Just take 180 and subtract 57.7, so 122.3. So I actually have two triangles now. I have this triangle that has all acute angles, and I also have this triangle that's an obtuse triangle. So not only did we have this problem where we had to solve the triangle, we now have two problems. We have to solve for two triangles, and you have to do both of these. So here are the two triangles that I need to solve, and I need to do both of these. The one on the left with 122.3 degrees for B would have a measurement for C of 32.7. And then I still need to calculate what side C is equal to. So I can use the law of sines to do this. Sine 32.7 over C is equal to sine 25 over 6. and I solve for C. And C is approximately 7.7. Over here on this triangle, on this acute triangle, if I take 180 minus 25 minus 57.7, I get 97.3. So that's angle C, and then I need to find side C, and I can use the law of sines to do this. And then use the calculator to find little c. So side C is approximately 14.1. Now the nice thing is that you want to remember the only time you're going to have a possibility of having two triangles is when you have an acute angle, a side, and then a shorter side. That's the only time that you're going to have to worry about this at all. The acute angle, a side, and then a shorter side.